Hey guys, how's it going? Today we are going to talk about factoring the difference of two perfect squares. Okay, so this is kind of like oops, this is going to be a special case. Okay, and this will be factoring what we what we normally call like Porky Pig, factoring the difference of two perfect squares. Okay, so we should know that difference means minus. Factoring, this is what we've been doing. We've been factoring, right? We've been finding the factors of the C term that add up to the B term. We got to talk about what perfect squares are. Okay, so if you guys think about what a perfect square is, okay, so first of all, let's talk about what a square is. You guys know, hopefully know what a square is, right? So you guys know that a square has all sides the same length, right? So again, you guys remember from a little junior high school geometry that a square has all sides of the same length. And to find the area in here, normally we would say length times width, but your length and your width are actually the same thing, right? So it's really like, I don't know, it's called length times length, or length squared, hence squared, okay? So let's go ahead and let's say this is 5. Well, that means that these are all 5, right? Because they're all the same length. And what's the area? The area would be 5 squared, which is 25. Therefore, we would say that 25 is a perfect square, okay? What it means is if we wanted to reverse this process, right? So what if they didn't give us that? What if they said, all right, we're giving you a square, and the area of the square is 25. How long is each side? So they're telling you the area is 25. How do you find the sides? Again, most of you guys should know the answer to that, and that is we take what's called the square root. Okay, so if we said, hey, what's the square root of 25? It would tell us, hey, what number times itself makes 25? And you should be saying positive and negative 5, but since it's a geometry problem, we'll just say it's 5. Okay, so it's the square root of 25, 5. That tells you that 5 times 5 makes 25. So these are what we call inverse operations, right? These do and undo each other, right? So when we say squares and square roots, that's what we're talking about, okay? So your perfect squares, okay, so let's hold on, one more example. What if I said the area of this circle is, now let's pick a nice easy number to work with. 10, right? 10's always nice, easy number. So what? So we're going to say that the area of the circle is 10. Well, if we want to find the side, we say, hey, what's the square root of 10? And you find out that you don't know that number. You know, some of you guys will yell out 5. No, it's not 5, right? Because 5 times 5 makes 25. So, you know, you go to your calculator and you say, where's the square root button? There it is. It's right there. Right? My square root button. So what's the square root, second because it's blue. So square root of 10. And we say each side length is that. Okay, now that is an irrational number if I've ever seen it. But it is true. That means if 3.162277766, again, that's an irrational number. It's going to keep going and going and going and going. Now, is that true? Yes, it's true. Is that useful? Probably not. But it's going to tell us that a lot of times when we take square roots, we're going to get some ugly numbers. Now, that number, if I square that number, it is true. It is 10. That number times itself is 10, right? 3 times 3 is 9, and the rest of this times itself is going to make 1, I guess. So our perfect squares are numbers that, when we take the square roots of them, are nice, normal integer answers. So your perfect squares are 0, 1, 4, 9, 16, 25, right? You guys, these should be looking familiar to you guys, right? 36, okay, 49, 64, what do we got? 81, 100, right? That's a nice number, right? And you can keep going for your 121, 144, right? 169, 196, 225. Okay. Again, if you guys want to know some other perfect squares, some good ones that are good to know. 400 is a good one to know. As is 625. Okay. So why are these numbers our perfect square? Well, this number is 0 times 0. This is 1 times 1. This is 2 times 2. This is 3 times 3. So in other words, if I take the square roots of this number, I get integers as answers. So we call these perfect squares because, frankly, because they have nice nice numbers to use as answers, right? So square root of 4 is 8, and you can fill most of these in. These are 13, 14, and 15. Okay, so I'll give you guys a few more. Normally, these are posted on the wall in my classroom. And again, 400 is going to be 20, and 625 is going to be 25. Okay. So again, these are your perfect squares. Okay, so these are numbers that you guys should know well. If I multiplication, if you're looking for a pattern on a multiplication table, and you see on a lot of these they're highlighted. These are the numbers that cut diagonally across your multiplication tables, right? So these are the numbers that are going to cut diagonally across here. Okay, so again, if you're looking for a pattern, that's your pattern. And if you want to use a multiplication table, please, I'll post one on the website. Please use it. Save that image now. Okay. All right. So meanwhile, back to the range. So that's all well and good. So your perfect square, your numbers are easy enough to identify. But what if your square? Oh my God, squares inside squares. What if you're a square? What if you didn't know? What if you said that this was, I don't know, x squared? Well, if we take the square root of x squared, we're going to find out that this is x. Now, this is a little more complicated, but you're going to see in a second, it's not really that bad, okay? That essentially that x times x makes x squared, which is true. If you guys remember, x equals x squared. So that is a perfect square. Even though we don't know what the number is, when we take the square root of x squared, we get a simple answer, right? What if I did this? What if I said x to the fourth? Well, that would be x squared times x squared, right? Because x squared times x squared, you guys all passed the 8th grade, right? So you guys are mom with this. You guys remember that x squared times x squared really means x times x times x times x, which is x to the fourth. So if we took the square root x to the fourth, that's going to be x squared. So essentially all you're looking for is an even exponent, right? So 2, 4, 6, you guys know your even numbers. X to the 8th, right? And then all we have to do is take that and cut it in half, okay? So again, when we see an even exponent, if we want to know the square root of it, all we got to do is cut that in half, right? Now, the last thing you guys need to know is what if they give you both? If I said, hey, what's, if I give you the square, and I said, hey, what if it's 16x squared? So I need to know, hey, what's the square root of 16x squared? Well, you're just going to go ahead and do those two things we told you. Well, what's the square root of 16? 4. You use multiplication tables, use multiplication tables. You use a calculator, use a calculator. Okay? What's the square root of x squared? X. So all you need to do is take the square root of the two components on the inside there. So 4x times 4x. And again, channeling our inner 8th grade. And if you forgot, you let me know. I will gladly go through and explain this for a day. 4 times 4 is 16. X times x, well, shorthand way, right? X times x is x squared. And if I went ahead and I did something crazy, let's put a big number in there. Let's put 12 in there. Well, very easily just cut that in half. 6, 6. Okay, good. So now we can actually get to what we were talking about, which is the difference of two perfect squares. Okay, so two perfect squares and difference. Okay, essentially it's going to look something like this. You are going to have some perfect square. Let's call it a square. It's a perfect square. And we're going to say the difference of that. And we're going to have another perfect square over here, which is going to be b. Okay? All you have to do essentially is say, hey, take the square root of the first one, the square root of the second one, give me a plus sign, give me a minus sign. Okay? That's it. Okay? All you're going to do is take the square root of the first number, put it twice, take the square root of the second number, put it twice, give me a plus sign on one, give me a minus sign on the other. So let's look at a few examples. I've taken these straight off of your homework. So first of all, whenever I assign you things from jmath.org, you guys should donate money to jmath.org. I should donate money to jmath.org. JMath is it's a website put together by a couple teachers out in Brooklyn, I think. And what they do is they compile old Regents questions. So these are questions from old Regents examinations. This is your standard, so this is whatever the standard is, but it's factoring difference two perfect squares. But the best part is if you go to the end, it will not only give you the answers, it will tell you what tests they're from. So now, if you see this IA, that means it's from Integrated Algebra. So this is from the Fall 2007 Integrated Algebra Regents, question number 6. This next one was from the January 2012 Integrated Algebra Regents, question number 1. Okay, the ones that you guys really want to focus on and in A1. Okay, that is the New Style Regents. Now, they've compiled all these questions, and you're going to see for these they don't really matter, but these are the ones you guys really want to focus on. So these are, January 2017, 2016. These are tests that they've given in the last 5 years since they've reformed things. So this question right here is from 1994. Now, I wasn't even in algebra in 1994. Okay, so any from mine? When did I take algebra? 99. 99 questions from no questions from the 1999 Regents. Okay, so anyway, these questions is kind of inconsequential because they're all going to be the same style. But again, we want to focus on these types of questions. Okay, so please do the questions and check your answers. I don't care. I give you guys the answer if you guys are mature students. Okay, so do as many as you can. Okay, if you have a hard problem with them, you can send me some questions. Okay, so here, x squared plus 16. Now, I'm sorry, x squared minus 16. Okay, now let's think about what we said. We said what was A, what was B, and what was C. Well, here, A is equal to 1. Now, B is not equal to negative 16. B, you actually don't have a B term. This is actually x squared plus 0x. There's actually nothing in the middle here. Okay? So what are we looking for? We're looking for the factors of negative 16 that add up to 0. Well, what are your factors of negative 16 that add up to 0? Well, that would be negative 4 and positive 4. Negative 4 plus, times positive 4 makes negative 16. Negative 4 plus positive 4 makes 0. Okay? So nothing has actually changed about what we're doing. It's just a unique case that we kind of want to be able to see. But long story short, square root of this is x. Square root of 16 is 4. Give me a plus sign on one. Give me a minus sign on the other. I know somebody's got to ask, does it matter if you put the plus sign first or the minus sign second? Absolutely not. Absolutely not. Remember, multiplication is commutative. It doesn't matter which order you do this in as long as you do the correct protocol. So again, so for this one, what's it going to be? It's going to be number 3. Okay. This one, they tried to throw you off. Okay, they gave you the 64 first and the x squared second. Doesn't matter. What's the square root of 64? 8. What's the square root of x squared? Again, take that exponent and divide it by 2. 2 divided by 2 is 1, so there's a little 1 there, a little 1 there. Give me a plus sign on one, give me a minus sign on the other. Okay, 121 minus x squared, 121 minus x squared. What's square root of 121? Well, you guys are the bomb, so you guys know your times table, so you guys know that that is 11. What's the square root of x squared? Well, you guys know that that's x. Give me a plus sign on one, give me a minus sign on the other. So 11 minus x, 11 plus x. Okay. Just remember, subtraction is not commutative, so I can't switch them around to give me this answer. Okay. Okay. So again, real quick here, one of the factors, they want to know one of the factors this time. So again, 4x squared minus 9. Again, we use square root of 4x squared, so take the square root of the number. Square root of x, and divide that exponent by 2. And square root of 9 is 3. Give me a plus sign on one, give me a minus sign on the other. What's one of the factors? X squared plus 3. Okay? The expression is equivalent to, remember, we're factoring these, okay? So if I said, hey, what's the factors? If I said, hey, 12 is equal to 3 times 4. These are equivalent, right? The factors are equivalent, right, when we multiply them. So we'll talk about that the closer you guys get to the regions about how we're going to go ahead and draft some things to see if they're equivalent. But the big thing for this is they want to know, hey, what if you factor this? So we've got 4x squared minus 25, okay? So again, things to recognize, perfect square minus a perfect square. So again, square root, so divide by 2. Give me a 5 on one, give me a 5 on the other. Give me a plus sign on one, give me a minus sign on the other. Okay? Good. So again, let's take a look. You guys can take a look at these. Should be no problem. I'm going to go over to the next page and show you guys some more advanced examples. So what do I expect from you guys tonight? At least the end of that first page, but I'm going to go over a few more of these advanced examples which you guys can do tomorrow. Okay? So it says factor completely. All right. I'm going to show you specifically this one and why people lost their mind. This was from a recent region, so I remember this question. Okay, so factor completely. Well, 3 is not a perfect square, nor is 27. So, oh my God, how am I going to factor this? A doesn't equal 1. What do I do? Well, think about what we would do yesterday. Is there a number that goes into 3 and 27? Sure. 3 goes into 3 and 27, right? 3 goes into 3 one time, and 3 goes into 27 or negative 27 9 times, right? So you can divide those out. So again, if you're not quite ready for these, focus on the ones up to number 10, and we'll worry about this stuff later, okay? So again, now can I factor this? Sure. I'll just have that extra factor. I got 3, what of x plus 3, x minus 3, okay? And that's going to be you right there, okay? If you got really stuck, you should be able to multiply these and find out, okay? The problem is that some of you will put, I don't know, they didn't put it as an answer. If this was one of your answers, you cannot put that because it's not completely factored. So they love to throw stuff like that in there. So please just be careful with those. Good. Written in simplest factor form, okay? Again, 2 and negative 50, not perfect squares, but they wouldn't ask you if you couldn't do it. So 2x squared minus 50, again, I'm going to divide by 2. And now all of a sudden, yes. Okay, good. So again, so go through these, see if there's a number you could divide by this one. If you divide them by 2, that becomes 9 and 25. So you guys, if you're okay with that, should be able to do up to number 16. Number 17 might be a bit of a challenge. So let's talk about number 14 and why number 14 drove people insane on their tests. Now, you want to look at this and you say, that's a perfect square, that's a perfect square, right? So you're going to go right, you say, all right, well, this is 9x plus 10 and 9x minus 10, right? Done, right? Square, oh, I'm sorry, 6. You want to do this, right? Square root of 36x, 6x, square root of negative 100, square root of 100 is 10, give me a plus, give me a minus, and I'm done, and my answer is not there. Why isn't my answer there? Well, I did everything I was supposed to, right? Now, this is factored. This is factored. I'm not going to deny that that's factored, but the problem is that you could factor it in a different way, and they wanted you to recognize it. So I remember it was one of these two questions, 14 or 15, were from a recent region. So I'll check which one it was. Now, this is a perfect square. This is a perfect square, but they're also both divisible by 4. 36 divided by 4 is 9, and 100 divided by 4 is 25. Now, when you divide both of these by 4, these are also going to go ahead and be perfect squares. Okay? So they got a little tricky here, and when they said, well, that's going to be 4, and now, what is this? 3x plus 5, 3x minus 5. Now, as we get closer to regions time, for some of you guys who are struggling with this, I will explain to you how you're going to do this problem another way, also about how you can graph these and compare them. So don't get bogged down. Don't think that you don't know what you're doing. You do, okay? So, same thing for this one. Oh my God, my answer is not here. So it says, which equivalent? So it should be 4x plus 6, 4x minus 6, which is not these, but you could divide this by 4 and this divide this by 4, okay? So take a look at some of these tonight. You guys should be able to do at least up to number 10. So 6, 7, 8, 9, 10. You should as well also be able to do, all of you guys should be able to do 19 to 21. If you guys have got those, please go ahead and finish out whatever you can and send me some questions, okay? But at least bare minimum up to 10. So is that 6, 7, 8, 9, and 10, and then 19, 20, and 21, okay? If you guys have specific questions, please send them. I hope this helps you guys. I will talk to you tomorrow.